Today we're starting Chapter 2. This is 2.1, Day 1, and we are going to be primarily talking about polynomial functions in this chapter. And so we start off with, what is a polynomial function? What does it look like? Now you'll see this box in your book. I got this directly from your book, but that makes it fairly difficult to decipher because this is just a bunch of math jargon here. So what I decided to do is, you want to take a look at that, that's fine, but I'll summarize the main points here. First of all, what this is saying is that there are no negative exponents in a polynomial, and we'll get to an example here in a bit. There are going to be no square roots on x, so if there are square roots involved, we'd have to be able to simplify in order for it to possibly be a polynomial. There are going to be no variables in the exponents, so I mean something like y equals 2 to the x. That's not a polynomial. It can't have an x in the exponent, so that doesn't work. And then the coefficients are real numbers, so there aren't going to be any imaginary numbers involved in these polynomials in order to call it a polynomial. So here's an example of what we're dealing with, just some to look at and decide, are they polynomials? Now, one other thing that we're going to do with these is we are going to take a look at a couple characteristics if they are actually polynomials. One of those things is the degree of that polynomial, which is just the highest exponent that is represented if you write it in standard form. And then the leading coefficient. Those two pieces are oftentimes things that are helpful to us when we're working with polynomials. So there's degree of the polynomial and leading coefficient. But let's first of all look at these examples and find which ones are polynomials, which ones are not. Now, in this particular case, we can't have negatives in the exponent. That was one of the rules, so this one's out. That one is not a polynomial. Another one that's pretty straightforward is the fact that we've got this big square root. Now, it would be okay if we could simplify the square root, but you'll notice the plus in there. We can't break this up because there's a plus in our square root. That just doesn't work. So that one is also not going to be a polynomial. Now, these other two are. And so if they are polynomials, if there's nothing from that list that gets violated here, then what we're going to do is find out the degree as well as the leading coefficient. Now, the degree for each one of these is just simply the largest exponent. So that's 3 in this case, and that's 4 in this case. This is the degree. So the degree is degree 3 polynomial, degree 4 polynomial. Then the leading coefficient is just the number out in front of that term. And so the leading coefficient in this case is 4. And the leading coefficient in this case, don't miss the negative here, but it's negative 2. So those numbers represent our leading coefficients in this case. And so that should help with determining, is it a polynomial first of all? And then if it is, these two characteristics will be fairly important.